All right, so this is the Chapter 7 practice test. It says test at the top, but this is the practice. The first one is evaluating the square roots. That means what does this square root equal? These are a bunch of them that you should already have memorized. You need to have this perfect squares from 1 to 15 memorized. And so we'll go through a couple of these that you may not know. The square root of 196 is 14. The square root of 36 is 6, because it's 6 times 6. Square root of 9 is 3. Square root of 81 is 9. Square root of 64 is 8. 225, the square root of 225 is 15. The square root of 16 is 4. The square root of 121 is 11. The square root of 144 is 12. The square root of 100 is 10. The square root of 169 is 13. The square root of 49 is 7. So I may have left a couple off there. Square root of 25 is 5. Square root of 4 is 2. The square root of 1 is 1. Yeah, and I think that's all of them. So those ones you need to just have memorized. The next problem is simplify the square root. So these are not perfect squares, but they have perfect square factors. So when I look at 162, well, if it ends in 2, I can always divide it by 2. And so we can break this down and write that as 81 times 2. And then there's two ways to look at this square root. We have the square root of 81 times the square root of 2. Well, we know the square root of 81 is 9, so it becomes 9 times the square root of 2. Now the other way to do it is to look at 81 as 9 times 9, and we continue to break it down. And as soon as I have a pair, I see that I have a pair. That means I have a perfect square, and so that number comes outside. We also get 9 square root 2. Number 40, our square root of 40, is 4 times 10. And again, if I see the square root of 4 is 2 as a perfect square root of 10, that gives me 2 times the square root of 10, because the square root of 4 is 2. Now, what if you didn't see it as 4 times 10? What if you wrote the square root of 4 as 5 times 8? And then neither of those are perfect squares, so we have to break that down some more. That's 5 times 4 times 2. And then that's 5 times 2 times 2 times 2. So you can get to the answer. Anyway, there's a pair of 2's, and we can bring that out, and it becomes 2 square root, and we multiply what's left underneath, square root 10. So we get the same answer, but there's different ways to get there. We just have to make sure we keep breaking it down and looking for pairs or perfect squares. 48 is one of those. We generally don't see the perfect square factor. We start with 8 times 6. And then 8 is 4 times 2, and 6 is 2 times 3. And 4 is 2 times 2, and then the other 2 times 2, and the 3. So now I have 2 pairs of 2's. And so that could be 2 times 2 on the outside, because each pair brings the 2 outside the radical, times the square root of 3. And then we multiply what's outside for square root 3. Now, if you saw that as 16 times 3, 16 times 3, we say the square root of 16 is 4, and the square root of 3 stays underneath. The numbers that are by themselves are not perfect squares, stay under the radical. The numbers that are the perfect square are what come out. And then 52, well, 52 is divisible by 2, so that's 2 times 26. And the square 2 times 26 is 2 times 13. And so there's my pair of 2's. So I get 4, not 4. This pair of 2's comes out as 2 square root 13. Okay, and that's how we simplify that. Okay, the formatting on this worksheet got really weird. So this next one is find the sum for numbers 3 through 5. We'll do number 3, and then I'll make a new slide for the other ones. Finding the sum means we're going to add up the like terms. We add up y squareds, we add up the y's. They have to have the same variable and the same exponent to combine them. When we combine them, we're just counting up how many y's we have. It doesn't change the exponent on the terms. So here we have 5y plus negative 4y. So that is 5 minus 4. That's y. So we have y. And then we have -8 plus -3. And that gives me -11. So I'm just combining my like terms. I did 5y minus 4y plus -8 minus 3. So we got y minus 11. So that's another way to look at it. Okay, here's 4 and 5. Again, we're going to combine all our like terms, so let's gather up what we have. This is the -p. It's going to combine with the 7p. We have -12. It's going to combine with the 4 because those are the like terms. And then we have 3p squared and the 5p squared. And we write these in order of the highest exponent first. So the p squared is going to go first. 3p squared plus 5p squared. So that's first, that's 8p squared. And the next is -p plus 7p. And so -p plus 7, that's -1 plus 7, which is plus 6p. And then lastly, it's -12 plus 4, which is minus 8. So my final answer is 8p squared plus 6p minus 8. And then number 5, we have two variables. So we're going to add up the c squareds, the c squared, and the c squared. We're going to add up the d squared with the d squared, and then the cd is going to be over here by itself. If we had another cd in the first parentheses, we would add it to that. And now this one, we generally just put in alphabetical order, so the c squared will go first, and then the cd will go in the middle, and then the d squared will go last. You will not get marked off for not putting them in a proper order, though. So here we have -c squared plus 5c squared plus the -cd plus the d squared minus 7d squared. So this is our combining up of our like terms. -c squared plus 5c squared is 4c squared minus the cd, and then d squared minus 7d squared is minus 6d squared. Notice my exponents didn't change, and I'm just subtracting the exponent or the numbers in front. Paying close attention to the fact like this is 1d squared, this is -1c squared. So now we're going to find the difference, which means we're going to subtract. And again, we're subtracting the same terms. Remembering that subtraction applies to everything. So here we have first our -5d squared, and we don't have another d squared in there. So my first term is -5d squared. My next term is 3d minus 4d. So I'm going to write that over here, 3d minus 4d, which gives me -1d, so -d. And then lastly, it's -3 minus -7. So let's think about what that means. -3 minus -7, that becomes plus a positive. So -3 plus 7 is plus 4, so positive 4. Now the other way we looked at it was we changed all of the signs in the second parentheses. So I'll move this to the side here, and we'll do it the other way. -5d squared plus 3d minus 3 minus, over more, 4d minus 7. So we said subtraction means adding the opposite. So we're going to add a -4, and we're subtracting a -7 means adding a positive 7. Then we'll combine up the like terms. So we have -5d squared again. 3d plus -4d is minus d, and -3 plus 7 is plus 4. So we get the same thing, but we have to make sure that changes both of the signs inside the parentheses, or all of them inside those parentheses. Okay, let's clear up some of this. All right. So that was 6. We're on 7 now. So we have -3x minus 8x. So let's change this. Change the plus to a minus, the minus to a plus the plus to a minus, and the minus to a plus. So we have 5x squared and 4x squared, and then negative 12 and positive 3. So we have, let's start with the x squareds. So 5x squared plus 4x squared gives me 9x squared. And we have negative 3x minus 8x, so negative 3 minus, same signs, we're going to add, so we get negative 11x. And then we have negative 12 plus 3, opposite signs we're going to subtract, so bigger one's negative, so it becomes negative 9. And number 8, again, it's minus, we're going to change it to plus the negative, negative, positive. We'll change all the signs inside the second parentheses. That's something I saw on the quiz that we were making mistakes with. So let's see what we have here. We have a t to the fourth, and I don't have a t to the fourth. I have a t squared and a t squared. I have a t and a t, and then I have the 10. And I don't have anything to add to that. So I'm going to add up the things that are alike. I start with the negative t to the fourth. And I say add up because once I change the signs in the second parentheses, I'm adding. So negative t to the fourth. And then I have negative 11t squared. Negative 11t squared plus negative t squared. So same sign, we're going to add. So that's negative 12t squared. Negative 12t squared. Then I have 3t minus t, so opposite signs will subtract, so 3t minus 1t is plus 2t, and then plus the 10, making sure that I've distributed that negative to everything in the second parentheses. Okay, so this next set says to multiply. We're going to multiply 4x squared times 3x minus 5. When we have a monomial times a binomial or times the parentheses, we distribute. We have 4x squared times 3x minus 4x squared times 5, which gives me 12x cubed minus 20x squared. When we multiply x squared times x, the exponents add, so we get x cubed. And that's the final answer on that. With 10, we also have to use the distributive property, and there's a couple ways to do that. It could look like m times m minus 8 plus 7 times m minus 8, and we can distribute both of those. We get m squared minus 8m plus 7m minus 56. So what I did was multiplied the m times the m times the negative 8, the 7 times the n, and the 7 times the negative 8. You can use FOIL to do that as well, and then we combine our like terms. Negative 8m plus 7m is negative 1m, so m squared minus m minus 56. Now another way I showed you was to do this vertically, like you used to multiply numbers, m plus 7 times m minus 8, and we multiply the negative 8 times the 7, and we get negative 56. Then we multiply the negative 8 times the m. We get negative 8m. And remember, I'm just showing a different way to do the problem. M times 7 is 7m. I'm going to make sure when I go to the second number I'm multiplying by, I'm going to move over and make sure everything lines up with its like term. And then lastly, the m times the m is m squared. So I have m squared minus m minus 56. Same answer, two different ways to get it. All right, let's look at number 11. 5m plus 5 times 3m minus 8. I really love the vertical multiplication. I think it's very organized and it works really well, especially when there's lots of terms to multiply out. So negative 8 times 5 is negative 40. It was negative 8 times 5. Then negative 8 times 5m, that's negative 40m. And then we're going to multiply 3m times 5. We get 15m, lining up my like terms, the m's with the m's. And then the last thing is the 3m times the 5m, which is 15m squared. And then I can add up my like terms, 15m squared minus 25m minus 40. And again, you can do that using the distributive property. You don't have to do it vertically. You can use FOIL horizontally or vertically. That's up to you, whichever one you like better. So number 12, c plus 5. I'll do this one horizontally just for variety here. We got c times 6c gives me 6c squared. Then I have c times 4 plus 4c. Then I'm going to do 5 times 6c plus 30c. And then lastly, the 5 times the 4 plus 20. Making sure I'm just multiplying each term by each other. Here are my like terms, my c. So 6c squared plus 34c plus 20 was my final answer. So on these, you just got to really pay attention to your signs. Make sure your positive and negative signs are good. And then make sure you multiplied and added correctly. That was 12. And then 13. When it says 5x plus 7y squared, remember to square something means to multiply it by itself. So we have to write it out. 5x plus 7y times 5x plus 7y. We're going to multiply it by itself. We can't just square the first one and square the last one. We miss the outside and the inside terms. So we get first 7y times 7y, which is 49y squared. And then we get 7y times 5x, which is 35xy. When I multiply x times y, I just get xy. And then I get the 5x here times this 7y. And so that is also 35xy. These are both positive. And then lastly, I get 5x times 5x, which is 25x squared. And then when I add it up, I get 25x squared plus 70xy plus 49y squared. That's my final answer. Okay, so here's number 14, b plus 7 squared. Also a square, so for 14, we're going to do b plus 7 times b plus 7. So 7 times 7 is 49. 7 times b is 7b. b times 7, 7b. And b times b is b squared. B squared. And I can add it up. B squared plus 14b plus 49. So remember, we're adding a 0 here in that spot, or we're leaving it blank so that we are lining up our b's and our b squared. And number 15, I'll do horizontally for you, just for those that like that method better. You can always do it on your paper the vertical way. So we start with b times b is b squared. And then we have b times 8 is plus 8b. Then we have negative 8 times b minus 8b. And then negative 8 times 8 minus 64. Now in this one, 8b and negative 8b equals 0b, so that we don't write that down, we just write b squared minus 64. And this is a sum and difference pattern. They turn out like this. All right, so these last 4 problems are multiplying as well. This is where I really like the vertical method. I'll do 1 vertical and 1 horizontal. So 16, I'm going to write n squared plus 5n minus 8. And I'm going to multiply by 3 plus n, but I can rearrange that if I like. So I can write that as n plus 3, as long as the sign stays the same on each of the variables. So I have 3 times negative 8 is negative 24. We have 3 times 5n, it's 15n. And then 3 times n squared is 3n squared. Then I have n times negative 8, negative 8n. We have n times 5n, which is 5n squared, positive. And then lastly, n times n squared, which is n cubed. And when I add that up, I get n cubed plus 8n squared plus 7n minus 24. Okay, number 17 is negative 5m minus 7 and 5m minus 7. So we're going to multiply the first ones, negative 25m squared. Then we're going to multiply 5m times the 7, and we get positive 35m. Then we're going to multiply negative 7 times 5m, negative 35m. And lastly, negative 7 times negative 7, plus 49. And we end up having like terms here that actually equals 0. So we have negative 25m squared plus 49. So that's the horizontal method. And it just gets confusing when the more terms you have, and then you have to kind of find them to add up the like terms. It's not so bad when it's just a binomial times a binomial. So let's look at 18. X minus 2 times x squared plus x plus 1. So we'll do this horizontally. X times x squared, x cubed. And we have x times x plus x squared. And x times 1 plus x. Then we're going to do negative 2 times x squared minus 2x squared. And we're going to do negative 2 times x, negative 2x, and negative 2 times 1, negative 2. And then our like terms, let's see, we've got an x squared here and an x squared here. So we start with the x cubed, and we have x squared minus 2x squared is negative x squared. And then we have an x and a negative 2x, so those are like terms, minus x, and then minus 2. So that's one way to do it. And the other is to do it vertically, and I'm going to do both ways on this problem. So we have negative 2 times 1 is negative 2. And negative 2 times x is negative 2x. Negative 2 times x squared is negative 2x squared. Then I have x times 1 is x. X times x is x squared. And x times x squared is x cubed. So I can add that up, x cubed minus x squared minus x minus 2. Okay. And then number 19, I'm going to just do vertically. D squared minus 6d plus 1. That's a 6. And then 5d plus 3. So I get 3 times 1 is 3. 3 times negative 6d is negative 18d. And 3 times d squared is 3d squared. And then 5d times 1 is 5d. 5d times negative 6d is negative 30d squared. And 5d times d squared is 5d cubed. So we get 5d cubed minus 27d squared minus 13d plus 3. And that's my final answer for number 19.